Today, I want to talk about software engineering from the perspective of how it's taught in university. More specifically, I will discuss what the introductory courses typically cover and what you can expect from a course in software engineering as a computer science student. This video is the first in a series where I will be talking about applied software engineering, explaining what you may be taught in university, what you will learn on the job, and why each piece of what you learn is important. I'm making these videos because I feel that they will be helpful to aspiring software engineers in terms of providing context for the things they're learning. Therefore, without any further ado, let's begin. If you're an aspiring software engineer, then you will most probably take at least one class in software engineering. The lectures of such a course will typically discuss three main topics: the software engineering process, object-oriented analysis and design, and lastly, design patterns and code smells. Let's discuss each of these in a bit more detail. The course I took started by discussing the software engineering process, and so will I. It sort of makes sense to do that in a course, as typically a course in software engineering will involve a large group project, so why not get the groups to form correctly and use the right processes from the start? Anyway, this part of the course is really easy to joke about, since it just introduces you to industry standard buzzwords, but there is actually useful content here. You learn about the software development lifecycle and the typical approaches to managing it. As an example, things like waterfall development model, agile development model, Scrum, and extreme programming are discussed. Now, the summary of these is that waterfall was used in traditional manufacturing, agile was made by cultists on a mountain in Utah, Scrum is what some MBAs thought is a good way to control devs, and extreme programming is basically what even more cultish devs thought would be a good way to control other devs. Okay, jokes aside, each one is discussed in detail and given historical context. There are benefits and drawbacks of each system, but I won't spend too much time on that here as there is more to talk about. Aside from team organization structures, more things are taught about project organization. Some are tools like Kanban, story points, and user stories, and other are parts of the project lifecycle like requirement gathering, testing, and more. All of these things have their own place and are useful to developers in different environments. Alright, let me quickly provide some color on this topic. After all, I've been a developer for a year and a half now. I have some thoughts to share on this. The first thought is that everything that is taught here can be abused and be done unbelievably wrong. I am really lucky to have worked in great environments, but I heard of power-tripping scrum masters, overbearing colleagues that do odd things in the name of XP or Agile, management using story points as a time estimate. As I said, each tool has its own place, and similarly, each one can be abused by either malicious people or incompetent management. Another thing that's worth pointing out is that as a new developer that joins an established team, you actually have very little say in the process. So adapt to what is being done and try to understand why the processes in place are the way that they are. Some teams benefit from daily stand-ups, some teams don't. Some teams benefit from having scrum masters and laying out software development in sprints, and others don't. Over time, you will learn the context and why things are done in a particular way, and once you do, feel free to give suggestions on how to do things better in a polite way. Okay, let's get back to the software engineering lecture content. After discussing the software engineering process, quite often the basics of object-oriented analysis and design are covered. Since a vast amount of modern commercial code is written in some object-oriented programming language, universities make you learn the basics of OOP or OOP. The history of OOP is briefly covered, and then you're forced into learning about classes, objects, inheritance, interfaces, polymorphism, and all the other crap. Right after that, you start being taught how to model real-life structures and relationships between them as code by using classes, inheritance, interfaces, and you would never guess, but polymorphism. This is where the most common examples you hear come in. You have an abstract class called vehicle that stores in it the number of wheels and color. Then you have two classes, car and motorcycle, that have an is a relationship with a vehicle that implements the abstract base class of vehicle. Okay, this is kind of boring for a YouTube video, so let me get over the boring part of this quickly. How do you transfer this abstraction information between developers without looking at the code? The answer is by making diagrams in UML, or the Unified Modeling Language. UML is the way to communicate the relationships between objects in a relatively simple way to other developers, and sometimes even other non-technical staff like management. Quite a useful tool, but this is very dry, so let's move on to providing you with some context from industry. My stance on these topics is that while they are dry and boring, you really should learn them well. This is because even if you do not end up working in an OOP language, knowing how to create abstractions for real-world things and communicate them to others easily is an incredibly valuable skill that is really important for a developer. Additionally, The things you learn in this part of the course lay the foundation of your programming knowledge that you will use in the remainder of the course and throughout your, hopefully, long career in software development. Speaking of you needing the knowledge about OOP, let's talk about the last topic that is covered in lectures of software engineering courses. The topic is design patterns and code smells. Let's start with design patterns first. The general idea about design patterns is that they are higher levels of abstraction that help dealing with certain common problems. Essentially, these become the really large building blocks of software. If you're writing a compiler, you will probably use a visitor pattern. If you have a complicated process to make a core type, then you will probably use a builder pattern. There are a lot of patterns that help with designing software, and they were originally described and talked about in the Design Patterns book by the Gang of Four. This book is often cited in software engineering classes, but I don't know how many people actually bothered reading it in the modern day and age. Another part of this section of the course is code smells. The name is actually based on intuition. Basically, if your code is shit, then it should smell like shit, and generally there are common symptoms of shit code which are called code smells. There are many different code smells, some of which are easier to explain than others. As an example, my favorite code smell is shotgun surgery. It's where you have to go across the entire code base and make tiny changes everywhere if you want to make a change to one class or interface. Typically, alongside the code smells, the course will discuss how to deal with each one and how to properly refactor code. It's a very interesting topic, and there is a lot of information to learn. Now, to provide a little bit of color, this part of the course is honestly one of the most important parts of any course you will take in university if you want to become a software engineer. Seriously. Design patterns are super important to know about, and the code smells along with the strategies that help with them are useful too. No, you do not need to memorize them, but you need to be able to look them up on a moment's notice, and also know at a high level when many of the more popular patterns are useful. Luckily, this is so important and so common that there are great resources out there to help you learn this stuff. One such resource is refactoring.guru. Great descriptions, analogies, diagrams, and use cases for all design patterns and code smells. Seriously, if you do not like your professor's explanations, then just go to this website and read there. I use it as my main reference very often. Anyway, that's basically all that is typically covered in the lectures of a basic software engineering course, so now let's discuss what you learn in the remainder of the course. Now, there is nothing wrong with learning in a lecture, but software engineering is something that is best learned by doing and making mistakes. Therefore, the things that you are most likely to take away from the course will be what is done in the lab, and what's done in the course group project that you will likely have to do. Thing is, a software engineering course will almost always have a large group project that you will have to put a lot of hours into outside the lecture and the lab. So let me explain what you can expect from the lab sessions, the overall project, and give you some advice on how to not have the project blow up on you. Let's begin this discussion by bringing up what is typically covered in the lab. Honestly, labs will be hit or miss depending on the TAs that run the lab. However, you can expect the content to cover the prerequisite knowledge that you need to do the assignments and the project, at least at first. As an example, the project for the course that I took was an Android app that would have to be written in Java and use Firebase for the backend. Therefore, the labs covered the basics of Android, data serialization and deserialization in Java, basics of storing and loading data from the Firebase NoSQL database, basics of Git, and I think that was mostly it. Essentially, the lab gives you the basics that you need to go off on your own and figure out how to actually do the assignments and implement the project. But that was the case for the first half of the course. For the second half of the course, the labs became significantly less structured or useful. Here's what I mean. The TAs in the lab session basically became the project managers that you would have to report your progress to. The lab session became a time and place where your entire team could get together and work on the project, and also the place where you would demo your project at the end of the course. Alright, now that we talked about the lab session, I will spend a bit more time explaining what the project could look like. The university that I attended had two main software engineering courses, the introduction course and the advanced course. The way that these courses structured their projects was vastly different, so I will share both with you. The introduction course project would be the same for every team. All the teams would be roughly the same size of 4 to 6 people depending on the semester, and the project would always be an Android app with a managed NoSQL database for data storage. The general project idea would change each semester, but everyone in the same semester would do the same project. Now, the advanced course was far more interesting. However, I did not end up taking it. For the project in that course, employers from all over Edmonton would come to the university and basically advertise projects that they want a group of students to do for them. The group size would vary per project, ranging from 4 to 8 people. The tech stack would actually often be up to the students to decide on, and the projects varied from Android apps and websites all the way to game engines and virtual reality applications. Now that you have heard of the two extremes of how the project can be run by the course, you should expect that courses at most universities will fall somewhere within that range of project choice rigidity. Anyway, let me provide some advice on how to not have the project explode on you, based on both mistakes that I have committed and the horror stories I have heard from other people that took the course. The first piece of advice is that you should pick your teammates well and try to minimize the number of pure randos that you take on for your team. Our team was 4 people that knew each other and 2 randos. Luckily for us, the 2 randos we took on were very good, but my friend had 4 randos on their team and they had an incredibly bad time. Now, I won't suggest doing something like having the people submit resumes. That might not fly very well, but do at least try to coordinate with your competent friends to take the course together. The second piece of advice is to not try and make sub-teams that specialize in some part of the app, but rather have everyone be a generalist. This is because you want to make sure that if some people are dying from assignments and midterms for other courses, progress can still be made by the rest of the people. This is a lesson that I learned through my own mistake. My decision to have 3 sub-teams almost sunk the entire team and I had a small falling out with a friend over it. The third piece of advice is to not dwell on the design too much before laying down the first lines of code. Essentially, you need to come up with the basic design over the course of 1 week, lay down some guidelines, and then get to coding as soon as you can. This will help you with managing the deadlines for the project. If you get stuck arguing about the design of your software for too long, you might actually run out of time in which to implement the app itself. Essentially, the trade-off between design and implementation is actually hard to get right, even in industry with highly paid managers helping out, so don't sweat it too much. To talk about the fourth piece of advice, I need to provide a bit more context. As part of our project, we had 5 requirements that were rather annoying. We needed very extensive Java docs, a well-organized GitHub wiki, a very up-to-date UML diagram, really detailed UI mockups and transition diagrams, and lastly, testing. Now, I'm not saying that documentation and testing are not important, just that the requirements were too strict and annoying to be useful. Anyway, what really worked for us is that one person took up the entire task end to end, and nobody was left to do all the annoying work alone. Last piece of advice I have for you is to properly read through all the requirements and make sure you aren't losing easy marks for stupid reasons. As an example, from my compilers course, one of the easy requirements was to not submit tests that you yourself fail. Guess what? 3/4 of the teams did and lost like 2 to 5% from the project grade. These are trivial mistakes that can be corrected in minutes. So listen to your professor and TAs to find out what those easy to lose marks are. After all, these silly mistakes add up and are really annoying to think about later. Anyway, that's about all I have for the advice on the project, but do not leave the video quite yet. I have something important left to say that you likely do not want to miss. Alright, now that you have an understanding of what you can expect to learn and do in a software engineering course, you probably have a lot of questions about the actual job of a software engineer. Do not worry, I will talk about a lot of specifics of the job in the following videos in the series. To give you some idea of what I will talk about, here is a rough list of topics that I intend to cover. Code reviews, version control systems, testing and build systems, tools, and last but not least, the soft skills that you need to have as a software engineer. All of these topics will be covered in their individual videos, and I will explain both how each thing is used and why they are important. Either way, I hope that this video was useful for you and that you enjoyed it. If you're watching this in the future when all the videos are already out, then feel free to check out the next one in this playlist. Also, the algorithm thinks that this video here is the one that you want to check out next. Feel free to leave a comment below. I try to respond to all of them whenever I have the time. Alright, I've been talking for a while today, so thank you for your time. Bye.